So I'm going to use this proof to show you how to use the rule of DeMorgan's in the ProofLab. So I've got these premises and this conclusion that I'm trying to get by a not elimination proof. So here I have my assumption is it's false that this whole disjunction that I want to get at the end. So I've got a negated conjunction here. So that's a perfect setup for DeMorgan's. So as soon as I see a negated conjunction, I just want to DeMorgan's that. So I'll click on the line that I want to apply the rule to, and then I'll click on this button that says DeMorgan's, and it shows me that it'll give me this disjunction with two negated disjuncts, which is what you get when you apply DeMorgan's. Okay, so now I'm going to have to, I've got a disjunction to work from, which isn't a whole lot happier. So I'm going to have to do some sort of or elimination proof to get my falsum. So I'll make the falsum my goal. Okay, and again, I've got two negated disjuncts, and I don't like those. So I'm going to try to get rid of those by applying DeMorgan's to them. And if I say, hey, I don't like that, I can apply DeMorgan's to that. So if I've got something that, so you can apply DeMorgan's either direction, and it'll give me exactly what I just had, which is how it should work. So you can apply it either way. I can't really show, I don't think there's anything here that I can use to show you how to do DeMorgan's backwards. I know how I can show you how to do DeMorgan's backwards. So let me reset this proof. I'm not going to complete it. We're going to be able to use these to get eventually. This one will be easy because here we can get our contradiction from this formula. We can get out not m and n by arrow elimination, and then we can get m and n. We can get not m and we can get m, and that'll be our contradiction. Here, this one's going to be a little tougher because, as you'll notice, here we've got not A and not B. And here we have A and B. If we could apply double negation inside a line, we'd be good to go, but it won't let us. Watch. So, let's see. That's going to put negations on it, but it wants to put it on the whole formula, which isn't helpful at all. And double negation elimination, it gives us a form and says, oh, if you have two negations, I can take those off for you, but I can't do it inside a line. Your statement needs to be a negation as a whole, a double negation as a whole. So that's not going to help us. So we're going to have to take that all apart, and then we'd have to perform double negation on it, and then put it back together. Okay, so we're not going to worry about that now. Let's reset this proof, because I can show you, if I sort of attack this problem a different way, then I can show you how to apply it backwards. So suppose instead of trying to get this by not elimination, we tried to get it by and introduction. So now we have the statement A, not A, or not B. So we could apply DeMorgan's on that. And if we thought, hey, maybe it's DeMorgan's form, the other form of it would be easier to get. So we do that, and we get not A and B. So maybe now we could try to get this by a not introduction. Okay, and we can see easily that's going to work, because now we've got A and B. So we could use that to get M and not N, and then we could get not N, and we could get N. So that would work. Now we can't apply DeMorgan's to this one backwards. Let's watch what happens if it... See, it shows us all these forms, and what we have is none of those forms because we don't have any negations either on the outside. So we'd either need to have a negation on the outside, or we'd need to have negations on both of the disjuncts. So either we need to be this form, or we need to be this form. And we're not either of those. I mean, or this form, or this form. And that's true even when you're doing it by hand. So if we were doing this, if we were allowed to do double negation inside of lines, then we could double negate this, and then we could apply DeMorgan's backwards. But we can't. So we would just have to try to get this by not elimination. That seems possible. And then we could apply DeMorgan's to this forwards to get rid of that negation. And then we get not A and not B, which we can apply to this. So this is actually a better way to do it than the way I started out doing it the first time. But I'm not going to complete the proof because that's not really the point of this tutorial. The point was just to explore how to use DeMorgan's. But you can see that this proof would easily work. It's going to be a bit of a long proof, but not too bad. So that's how you use DeMorgan's in the ProofLab.